What are intrinsic semiconductors? A perfect semiconductor with no impurity is intrinsic in nature. Germanium and silicon are the most common types of intrinsic semiconductors. They both are tetravalent. It means they have 4 valence electrons in their valence shell. Now, look at this figure. The valence electrons in germanium are in the 4th shell, while the valence electrons in silicon are in the 3rd shell, that is, closer to the nucleus. This means that the germanium valence electrons are at higher energy levels than those in silicon, and therefore these valence electrons in germanium require a smaller amount of additional energy to escape from the atom. This property makes germanium more unstable at high temperatures. It results in excessive reverse current. This is why silicon is a more widely used semiconductor material. It is used in diodes, transistors, integrated circuits, and other semiconductor devices. Now we will understand crystal structure of silicon. Silicon atoms are arranged in a definite symmetrical pattern, making them a crystalline solid structure. A crystal of pure silica, that is, silicon dioxide or glass, is generally said to be an intrinsic crystal. It means it has no impurities and therefore it has no free electrons. Now, look at this figure. It shows how each silicon atom positions itself with 4 adjacent silicon atoms to form a silicon crystal. A silicon atom with its 4 valence electrons shares an electron with each of its 4 neighbors. This sharing of valence electrons produces the covalent bonds that hold these atoms together. These pink signs represent the shared valence electrons. Covalent bonding in an intrinsic silicon crystal is shown in this figure.